Start now. So thank you everyone for attending. It's a great honor for me to speak here at Hacking the Box, sharing my experiments with JWT and application security in general. Today I will be speaking about JWT security, and the talk is practical approaches for testing and breaking JWT authentication. So my name is Mazin Ahmed. I'm a freelancing penetration tester and information security specialist. Also founded the security startup called Full Hunt. It's the next generation vulnerability intelligence platform. Before that, I was working as a security engineer at Proton Mail, and I'm also an occasional bug bounty participant, where I was in the top 10 in 2014. I also got acknowledged by Facebook, by Twitter, Oracle, and LinkedIn for reporting security vulnerabilities to them. And let's start. So once upon a time, I was participating in this CTF competition with my team. When I was participating there, my role was to take over the web application challenges. At that competition, the most difficult challenge was marked as extreme. It was a web application challenge. And once I inspected it, I know that it's a JWT challenge. So it was a login page, and you have to get admin access to the application to get the flag. You have user access, so there is two ways to do this. The first way is by brute forcing the admin password, which does not make sense. And the other straightforward solution is to break the JWT authentication at that point. So I started inspecting this challenge and trying to solve it. Eventually we solved it and we won the competition at that day. But then I realized that there is a lot of work that should be put in JWT, especially that is being used a lot these days. Anyone is doing AppSec here? Okay, great. Some people are doing AppSec. So have you encountered JWT before in any application? Anyone tested the toolings for JWT that is public? Have you tested? No? Oh, it's fine. So at that CTF, it was a 4-hour CTF, and I have to solve it. After learning what JWT is and how to work with it, I used the toolings that is publicly available at that time in order to try to solve the challenge. And based on that, this motivated me to do these experiments. And we'll discuss it later. So first, we're going to talk about JWT and the background of it, then how it works, web implementation, how to attack it, how to secure it, and everything. At the end, we have a small tool release for JWT. So JWT is an RFC that was proposed back in May 2015. And basically it's JSON object, the concept of JSON objects, and digital signatures, or cryptographic signatures, composed together and gives you JWT. So it's something like this. The base64 header, base64 of a header, base64 of payload, and signature. This 3 chunks composes or makes JWT token. This is the header. It looks like this, composed of 2 keys. The first, the alg is the important part, the algorithm that is being used for signing the token. And the second part is, if you control it, you own the system. You can put whatever data that you want, and as far as being signed correctly, you are secure. This is how it's being signed. So whatever cryptographical signature technique that you are using, being applied with the chunk that you originally gave it to it. Eventually, this is how it looks. The red side is the header. The green is the payload, the data that you provide. And the pink one is the signature. Typical setup for JWT goes this way. Let's say I have a web application that is using JWT. So a user would send an HTTP request with their username, their password, or their email and password, their credentials, to the system. The system would check it within their database and check if the credentials are correct. And if it's correct, it sends a signed JWT token to the user, and then asks the user to forward it whenever they do any functionality there. Then whenever the user sends it, it won't be checked fully as is being checked at the beginning, which reduces the headache for doing authentication. It only checks if the token that is being sent is signed or not, and that's it. If it's signed, it will check the value of it, whether the user have the same ID, for example, or whatever, and that's all of it. So it's quite simple to use. And now we go to the attacking part. We can see from this that if you were able to break a JWT authentication or authorization system, you broke the entire thing. There are SSO single sign-on systems that are being based on the JWT protocol. Once you break it, you break the entire enterprise access control. First way to do it is straightforward. Brute forcing the secret key. If the company is using a weak password or something that you can basically crack, but the tracking at that point won't be a remote cracking, so you won't be sending a lot of requests to the user. You would just obtain a valid JWT token, and once you obtain it, you would be able to crack it offline, which is great. You can take the entire attack to your field. With the resources that you have, you can win. That's the first way. Second way, so how to obtain the JWT token? Typically, if it's being used in a web application, you would get it in the response. So when you authenticate with a login page, for example, you would get it in response if your token is correct, if your credentials are correct. So same way that you get the session cookie, but in this case, you won't be getting a session cookie like the typical session cookie. You would get a token from the server. So in this case, let's say you have a user level, a user access, typical user, not an admin level. And if you have this valid token with this criteria, you can do the following. I will show you now here. Let's get back to this one. This one. So if you obtain a typical token like this from the server side, you would then go to this one, decode it, and once you decode it, you can see the subscription ID for the user. You can just change it, and once you change it, if it's signed, this is a tricky part, if you signed it correctly, the server will accept it. If the server accepts your token, the signed token or the manipulated token that you tampered, then you broke the system. The point, or the key point, is if you modify the token, it won't work because it's not signed with the cryptographical signature that was made for it. It's easy to obtain it. This is the easy part for this one. So once you get the keys, once you try to brute force it, you got the valid key that the company is using for signing the tokens. You can easily issue a new token and with the value that you want. Then you send it to the server with what you want, and boom, that's it. You broke the system. The second way is signing a new token with something called the non algorithm. As discussed before, we were discussing previously about how RFCs are quite a difficult thing. So in the RFC, they have this specs called the non algorithm, which means a valid JWT that is unsigned, with no cryptographical key, with no token, with no key, with no password, with nothing. But it's a valid one. If you provide this one to the server and it accepts it, then it means that you can issue arbitrary tokens, and you can use them to manipulate or compromise the authentication system. Basically becomes anyone. You can become anyone in that case. The third way is a way of fuzzing the system. You can manipulate the cryptographical method that is being used. So instead of saying that you are using HS256, you can say that I'm using HS512. And then it may break the system. Whatever error can happen in the background, we don't know. Or it can yield with some useful errors that can help you in going further. It's something that's worth trying because the importance of this system, but it's not something that is bulletproof to get you access to the server or to the system. So this part, what happened to be the thing that I was doing while in the CTF, the JWT testing tools at that point. The first tool I have is called JWT tool. This is one of the tools that I used in the CTF. At that challenge that I was participating on, the way to solve it was to sign a token with the known algorithm and then send it back to the server, and the server will accept it. This tool is capable of doing the same thing, signing a token. You provided a token, it will sign it with a known algorithm. So I used it. Apparently, it did not work. So there is a lot of issues in this tool. And one thing that is not that good on it is using custom parsing for base64 strings. So developers are using official JWT libraries that are following the RFCs. And so there is no actual reason to reinvent this part. Instead, we should use the same thing, or same libraries that developers are using to break their thing. So they were not using this one, they were using custom parsing. I believe this is the reason that made this tool issue an invalid token for that challenge. And one thing, they are having like a JWT-CRACKER, but the thing is the cracker did not, he's using a linear approach for cracking. It's somehow fast, but it's still Python, so it's not the fastest because of the global interpreter lock. Second tool I used was C-JWT-CRACKER. It's written in C, but the thing is it's unstable. If you can see in the screen here, this is from the project repository. It says that there's some sort of an issue in their base64 implementation. At that case, when I was in the CTF, I took the same tool and issued a token that is, the password was like 1234, and I was trying to consistently try to crack it. Every time it gives me different results, which means it's totally unstable at that point. Third tool was JWT-CRACKER. It's a really nice tool, but it's only made for HS256 JWT. And yeah, now introducing JWT-Poon. When I wasn't able to solve it in that competition, I started to scripting my own thing, which is very simple, very library dependent on the thing that is originally made by JWT library that developers use. And then I made these scripts, and then I made it as a tool for me to share it with you guys. So it's simple scripts. Some scripts are even like 5 to 10 lines because it's dependent, and I've shown all of the work to the library, and covering all the discussed attacks, automated, and of course includes some sort of a JWT password cracker with some software engineering in mind, so the bugs that I showed you now won't be there, hopefully. And of course it's in beta release, so I'm very open to feedback regarding it. First script is JWT decoder. Very simple one. You just give it a JWT token. It will decode it to you and gives you what data there. It will be very handy if the authentication system is leaking more info that is not supposed to be shared in the token, because if you receive the token, whatever in that field can be decoded and people can see it. So if you're let's say, sharing phone numbers, for example. It won't be a nice thing. The second script is JWT any to HS256. It's a way to fuzz the JWT part. You can just give it a token, and it will change it to HS256, a signed one, with a different key. And you can just pass it to the server and see what will happen. Another one, this is the same concept I used in solving the competition. You give it a signed token, it will generate a new unsigned one, and then you can try it. This is how I solved the challenge at that case. Third one, or the cracker one, is the same concept of cracking JWT, but with some software engineering in mind. This one is multi-threaded. Fun part, what happened when I was writing this one, that although it's multi-threaded, it should be fast, but it wasn't because of the global interpreter lock in Python. So it wasn't the best, but it worked. What I did is I rewrote the same thing in Golang in two different ways. The first way was also in a multi-thread approach. And it was fast, but it wasn't as satisfying. What I figured out after this, that when you are writing a cracker in Golang, or anything that requires a lot of resources, when you break it, we have 1 million passwords, for example, in your word list. And then you will split it in split it into workers, and the worker will work at the same time in order to crack it. And you have to do all these processes. But if you write it in a single thread, it will be much faster, somehow. Because you eliminate the process of reading the entire word list, initializing threads, splitting the data into each thread, and things like this way. So yeah, it's also there. But also the testing script is in the repo. And we have a small demo. Can we play it? It's fine, it's fine. So the slides will be shared in the repo too. So you can watch the video later. It shows the speed of the tool, the cracking tool in real life. The word list is around 1 million entry, and how it can try to crack it within seconds in different algorithms and in different things. So this is the repo that will be public right after the talk, if you would like to take a screenshot. So the recommendations. So first, always verify the JWT header, if it's a valid one or not, if it's being tampered or not. Second thing is always verify the algorithm, if it's the same thing that is being used in your company, or someone has modified it to tamper it or to try to fuzz it. Never trust the non-algorithm. Fun part here that Golang, they have their own library for, it's called, I'm not sure what it was called exactly, but the official JWT library for Golang is not following the RFC. So if you provide a token with a signed with a non-algorithm, it won't accept it. It's against the RFC, but it's better somehow. So whitelist the used algorithm and always verify it. Rotate your signing keys periodically, because cracking will happen offline, and once you do it offline, how fast is your performance and your resources, which will mean how fast would it be to crack it. And yeah, so don't expose the important client data in JWT as we spoke earlier. One thing that I would totally recommend is adding a claim to expiration for expiration. This would overcome the issue of non-expiration thing in JWT. So JWT is a stateless protocol which means that you cannot revoke the token unless you revoke the key. But one thing that you can add is add an expiration of, let's say, 3 months from the day of issuing, or 1 week, depends on your app. And once you do this, you can check if it's signed or not. After you check this part on the function on the validation function, you can check if it passes the time of expiration or not. And then you can have the same experience of an authentication system in a stateless protocol. And key size matters. The bigger your key, the more difficult for people to crack it, like password attacks 101. And yeah, thank you guys.
Mazin, are there any questions from the audience? Then we do have a few from Slido here.
So the first one is, do you need the admin username to manipulate the token? Yes, it depends on the application, but in general, yes. You either need the admin username or the admin ID, for example, to manipulate the token, do the correct thing to get access to his account or her account. The same thing, you can, even if you did not get the admin username, let's say that the application is mostly using emails or using IDs, you can change the ID from the ID that you have to another ID of another user, and you will get access to his or her account once you send the correct thing. That's for the first one. What's the average time? So the second one is, what is the average time to brute force a secret key for a token? The average time is totally debatable. You cannot know it easily, but it depends on your word list. It depends on how difficult is a password. It's totally debatable. You cannot make sure how fast is it, but you can do the best efforts in making your tool as fast as possible, so that it would help you in doing the cracking. And you should try your best in having it more reliable as possible. So for example, one of the solutions was to use Hashcat. So Hashcat somehow supports JWT, but it's not very reliable. And the module for JWT is not very reliable. Hashcat is very reliable, but this one is not. So that's why I had to write something else. And other recommended specification you can use to make the brute forcing infeasible. Yeah, so there is actually. So using a key-based approach, using an actual key, would make it much better instead of using a single token of 12, 14, 100 password length. It's a much more better alternative. Third one is this type of vulnerability applicable to any other protocol? Yes and no. So if the application is using JWT, then it's related to it. But there are a lot of systems and protocols that are now using JWT. Like SSO is a lot of SSO systems are now using JWT. Which means that if you break JWT on an SSO system, then you have break the entire SSO system, which is another protocol. So it's quite also debatable on this one. If the secret key is not found in a word list, is brute forcing applicable for secure passwords? No. So if you cannot find it in a word list and you have tried all the resources of word lists and like password entries that you have or you can generate, and all of them did not work, so you cannot really brute force it or break it using this technique. Okay, is it possible to have a separate secret key for each user so that when a key is cracked, it doesn't affect affect others? Yeah, this cannot be possible because it's like a single point of failure. If the token, the signing token for this one is compromised, then the entire thing is compromised. But this makes me think one way to do it in a way that can work with two authentication systems is to have a different SSO for admins with a different signing key that users have, so that you can somehow segment the admins from the users. I've never seen this being done, but it's good. It just came out of my mind when I read this question. But typically, it's not possible. Yeah.
Are there any more questions now from the audience, maybe?
Please.
So I've seen a video yesterday. Somehow it's related to your topic. There was a web application that is vulnerable to SQL injection. So the person trying to break into the administration page got in by injecting the web application with a string. So he is in the administration page, but he doesn't know the username and the password. So once he is in, it'll say hello, like a name. So this would be the username. So what he did basically was he inspected the element. He went to the network cookies, and then he got the JWT token. He just Googled JSON Web Token decoder, and then he copied it and pasted it in the website. And then it broke down the three elements, which is the header, payload, signature.
Yeah.
He saw the hash of the password. So basically, he copied it and pasted it in the hash identifier. It was MD5. So he went to MD5 decoder. He put the hash, and the actual password showed up. So he got the password after getting in the administration page by injecting the web application with SQL injection.
Okay, this scenario is quite difficult because let's say the MD5 hash was for this particular user, right? Was it for the particular user or it was for the admin?
It was like the hash of the password.
Yeah, but I mean the JWT token that he obtained, it was for the admin? Or?
Yeah.
Yeah, okay, that would make sense because the token would store different data. So like if a user, this is one thing that we actually discussed here. So you should not put this type of data on the JWT payload. So you, like if I'm building a JWT system, authentication system, I would have like the user ID, the user email, and probably that's it. I won't be putting the actual password because people can decode it. And once, if my token is leaked, then other bad things can happen, which is in this case, the user has extracted the same thing from the user. But in that scenario, the hacker could have just used the same token and replied to the application, and he would have got the same access without even trying to crack it. It's a good scenario, but he can do it in an easier way that would fit the JWT thing. Yeah. So we have another. Is pass the hash applicable in this case when cracking the password is not possible? Well, I wish yes, but unfortunately not. Pass the hash is not applicable in this one. You need to, you have some sort of text file or string that you need to sign it in a way that the application would accept it. There is no way to perform typical pass the hash techniques in this case, in this particular protocol. But you can try your best in fuzzing the authentication into finding ways to get in.
Okay, so we have actually been able to get the demo to work. Would you still like to play it?
Well, sure, why not?
No, let's do that.
That's for the speed, actually. That would be nice. This is more than 1 million word list. So this like the same file, like different tokens with the password 1234. And it's inside the word list, and you can see how fast you can load the word list and crack the password in different hashing algorithms. This is 3 different ones that are majorly used in real web applications. authentication systems. 1, 2. You see, like 2 seconds. That's not my laptop. But yeah, okay, another one. Why is JWT being stateless seen as a benefit over normal cookies? Well, that's a good one. So having a stateless protocol is really nice because you offshore the entire authentication part in terms of checking and performance and stuff like this to something that can be easily done in less resources. So having a normal cookie, you would have to store let's say for example PHP. PHP would each user that is being authenticated with typical PHP authentication with the cookies and everything that is going with PHP. You would use each token will be stored in the system, whether in memory or in file disk. But in JWT, you do not have to store it actually. You just have to issue it and sign it correctly in a way that when you see it again, you would know that this is the token that I issued. It's not something that someone tampered. In fact, a lot of the modern systems are using the same technique now, in a way or another. So for example, the Janjo is using the same technique, not fully JWT, of course, but the same concept of a stateless protocol or stateless authentication. Flask authentication in Python is using the same thing. Definitely there are a lot more frameworks that is using the same concepts of stateless authentication now, because it's much reliable and much easier to implement and much easier to deploy and requires far much less resources than typical normal cookies.
Are there any more questions? Then can I give it a big applause for Mazin Ahmed?